Okay, so we're gonna go through this. Mine's on the board. They are in different orders, so I'm not gonna be able to say raise your hand if you have a question on 1 through 5, because your 1 through 5s will be different than your neighbors. So if you wrote down stuff as you were taking it, maybe, or you can go into yours and open it and see if it matches the question. So number 1's asking me, determine the intervals on which the function is increasing, decreasing, and constant. You need to remember that intervals of increasing, decreasing, and constant are separated by commas. If you forget that, it says it in blue. If you accidentally put the union symbol, I will go back and give you credit, but please read the blue suggestion that is telling you to use a comma here, okay? Remember, increasing, decreasing, and constant are where you imagine a person running the graph, right? And from left to right. So
y'all are on. Okay, then I'll just watch it.
that is hard. What are your numbers?
You just plug in the numbers. Yeah.
Okay, we'll be back one more time.
Okay.
Raleigh's cake.
Are there any questions on this one at all? I don't know how to do this. It's a little bit different. Yes.
They all have the same format, like ice questions, like crossing legs.
Yeah, that was my first question.
I think all our questions have.
Are you sure?
Do we all do that? Well, we've only done one question so far, so.
Well, yeah.
Okay, well, let me go to the next one then. If they do, then that'd be great, because then I can just,
How do you know the second one? The graph.
let's go to 2.
Yeah.
Oh,
Yeah, they're the same. Yeah, I don't know.
Yes.
They're the same.
okay, awesome. All right, so then you should be filling in. So these are in the same order, which makes this a lot easier. So we're looking at question 2. This has 5 parts. Graph the function using the given window. You need to be able to distinguish the function from the window right here. You will need your graphing calculator. Oh, wrong one. How about them balls? Sorry. All right. Okay. When you go to your graphing calculator, you're going to go to y equals and enter that in. Make sure you are entering it correctly. Make sure I'm entering it correctly, because this calculator software sometimes doesn't respond to touch very well. Okay, and then go to your window. The way the window is laid out is always x min, x max, y min, y max. So you got -3, 7. Your x and y scale by default need to be 1, unless they tell you otherwise. then you hit graph. So I can see that D is the answer choice. Then it's going to say, okay, the function is increasing, decreasing, has a relative max or a relative min. Okay, in order to find these two questions, the increasing and the decreasing, you've got to know, I'm going to go to green so that it doesn't overlap with the blue. In order to know where it's increasing and decreasing, you need to know where it's switching. Imagine a person running it. So if a person was running this graph from right there, they always start on the left, they would be doing what at first? They would be decreasing, so I guess I should have made it red. Oh well. They're going to be, that's the air. Sorry y'all. It's going to be decreasing till he gets about right there. Right? Then he's no longer decreasing. Now what's he doing? He's slightly increasing till about right there. That's a little off. Then what's he doing? Then he would be decreasing. Yes? Now you have to use the calculator to tell you what are those points. You can't guess by just looking at it. You need to know. In order to find those points, you have to relate it to the words max or min, which is why the next two parts are saying where's the max and the min. Actually, it should, if this were me writing this test, I would put the max and min questions first because you have to find them first in order to then say where it's increasing and decreasing. This would be considered a what? That's a relative min. And then this would be a relative max. So you're going to have to go to your calculator and hit second calc. You've got to know these steps. If you hit min, then you've got to go to the correct one. It will not calculate a minimum if you're telling it to find this value right here, because that's not a minimum, that's a maximum. So you do have to be telling the calculator to find the correct one for it to actually do it, okay? So let me erase some of this so I can walk you through those steps. So I'm going to do second calc. I'm going to go for min, then I'm going to look back at the graph and remind myself that I need to know where it's bottoming out. It's bottoming out right there, so I'm going to go left of it, enter, then I'll go right of it, enter, and then I'll go to the middle. And it tells me the minimum is 0.999999, y is negative 18. This happened to someone. Audrey, was it you? You entered the 0.999 and it was actually 1. Yeah. If that happens on the test, I would give you full credit for it. But you can I think we can see the pattern here that if it's going to produce that as a number, it's safe to go ahead and round it to the the nearest whole integer. So this would be 1 negative 18. So I'm going to come right here. This is what you would do on your test. You would go to the space provided and you would sketch the graph as best as you can. And then you would come right here and say, okay, so this minimum is 1 negative 18. Then you would repeat, and now to find the relative max, go left of it, and go right of it, and then guess. So the relative max is 3 comma negative 14. You go back to your paper and you would put that this is a max at 314. Then you would remind yourself of what the question was asking. Increasing, decreasing, right? Go to mine, because you're not gonna get to use that one on the testimony. Go ahead and switch to that one. I mean, you're getting decimals and I got numbers. Pull it up on there and then show me. Alright, so it's decreasing. Let's see, I'll do red for decreasing. It's decreasing here. Then it's increasing. Then it's decreasing. Remember, you need the x values for increasing and decreasing. So the x values are that it's coming from negative infinity and it stops decreasing at 1. Then it's increasing from 1 to 3. Then it's decreasing again from 3 to infinity. Okay. Let me see yours. Read your functions for me. I see what you're saying. Does it say on your thing, like if you move around? Wait, I got a pretty number. Oh, okay. It's your max that's coming out weird. Okay, I got a pretty number on your max. I'm gonna clear it. I want you to do the max. Oh, that's mine. Your max is here.
Yes, I did.
I love that the max is in between. It's not. It's not.
Oh, I did. I did.
Max. He wants a left out. Where's the question? Give me a left out. This is your max, right here. Right? This is your max. So you need the cursor to just be slightly to the left of it. It already is. So hit enter. Now go to the right of it. All the way over the curve. Like over the hump. There you go. Now put it in the middle of the hump. There's your pretty numbers. That's what it was. Alright, any questions on 2?
I've got one.
Well, after you find your min and your max, then you just have to differentiate if it was a decreasing or an increasing interval. Remember, you're using parentheses. The second part, I just realized I didn't answer the second part. Let me answer that in a minute. No, 1, 2, 3. Remember, when you see the word interval, I want you to think of the phrase from this number to this number. It's not a point, not a fraction. So this is saying from the number 1 to the number 3, he's running up. The x's. So this one, you're doing your first So like right here, look at that. He's up here, right? He's running the graph. He's decreasing until bam. He's no longer decreasing. Now he's going to slightly run up to bam. Then he'll start decreasing again. So what you're doing is you're writing, right, because this is the x. Oh, I see where you were asking. It's the x coordinates between that min and that max. So I'm getting my numbers. I'm not even looking at the whole, well, I'm getting my numbers from this x value. So this x value is the number 1. This x value is the number 3. And that's it. Those are the only numbers I need. The decreasing is coming from negative infinity, and it stops decreasing right here. Then it's going from 3 to infinity. Look at that blue. It should say comma. The only ones that are union are domain range. If he's not feeling good, then just text me and I will go get him and take half an hour. The next part says, tell me the relative max and tell me the relative min. You need to remember they want the y value first, then they want the x value. I forgot to put the negative right here. They want the y value, then the x value. Okay? If you forget that, it should, like, raise a red flag when it says right here, occurs at what? X equals. So that should tell you clearly you're only putting the x coordinate in that box, which means here they want the y coordinate. Okay? Alright, let's go to the next question.
So,
Yes.
one question. I was doing a problem when you were doing it. How do you put that in the calculator? Because the brackets I don't know how to do. To graph it? I graphed the equation and it's wrong.
This is the equation. This is the window. The brackets are letting you know what to set your window at. So you can see.
I guess I typed it in wrong then. Because I typed in the equation and it didn't look anything similar.
The brackets part does not go in y equals. It goes in the window button.
Oh, there's a window button? I guess that's what it was.
Yeah, and the first two numbers are the x min and the x max. And the second two numbers are the y min and the y max. And your x and y scale need to be 1 by default. Number 3 is evaluating a piecewise function. You just need to remember to focus on the rules first. If I'm evaluating g of -6, that means I'm plugging what number in? -6. You got to look at which rule -6 fits in to know which equation to plug it into. -6 falls in this rule right here where it says x is less than or equal to 4. You just replace the x with the number you're plugging in and ask yourself if that's true or false. If it's true, then that's the equation you use. If it's false, it means you don't use that equation. What?
We use the right part of the equation.
So the right part of the rules.
It says, like on mine, it says G -4.
put -4 in the rules that yours says, and then which one is true.
Well, that's the answer. Yeah.
That once you know which rule is true, then you go left to the equation.
Okay, that's what that's the answer. Right.
Right, you type -4. No, you don't type the equation as the answer. You have to enter it in X and find the number. Find the answer. So like in mine, -6 is less than, so mine goes into X plus 5. So -6 plus 5 is -1. That's why they have that. Don't let this one throw you off. It says when G is 4, it says when G is 4, plug the 4 in, focus on the or equal to, and that would be the very first one. So I would plug it into X plus 5, so 4 plus 5 is 9. Are there any other questions on this problem? Because there's no other parts to it. That's it. It's just now you plug in 9. Okay, number 4. Graph the piecewise function on the right. I know this one gave a lot of people trouble. I'm going to show you a technique for eliminating 2 of them. You just have to look at the rules. The rules will help you eliminate 2 of them. If your answer choices, actually let's eliminate the 2 and then I'll say what I was about to say. So looking at the rules, this means shade left, right? Correct? This means you are going left in some manner. I don't know how the line goes, but it means you're going left. This means this would be an open circle and an open circle. This means you are in between, right? And then this means you are going right. Why are they open circles? Because it says just the less than. It doesn't have the or equal to. If it had the or equal to, then this would be 2 closed circles, right? Now, which ones can I eliminate based on what I just looked at? I can eliminate A and I can eliminate C because look at the middle piece. The graphs go in the order that the equations are written. The very first equation is the far left graph. The middle equation is the middle graph. The bottom equation is the right graph. They go in order. So I can eliminate A and C because look at the middle graph. It's 2 closed circles, and that says clearly open to open. Now on the test, if you eliminate the correct not possible answers, that puts you down at a 50-50, which hopefully you know how to do it, and I'm going to show you how to do it. But let's say you get it wrong, then I'm going to give you partial credit because there is only a small difference between the 2 other choices. Does that make sense? Like if you picked A or C here, you got it wrong. You didn't even read the rules. But if you picked B or D, if you picked B, because the correct answer, put green. The correct answer on mine is D. If you pick B, I'll give you partial. Because your rules are right, but your equations are wrong. Mine's open because of the signs right there. So then yours is not. Yeah, no, that's, you picked that. That's not right. Look, open to open. So it's either that one or that one. You see the difference? You see what I mean? So you see that or equal to? That means that one's gonna be closed. This one that's just a flat line at 2 is open to open, which means can't be that and it can't be that. Yeah. Yeah. All right, so now how do you actually get the right answer? Okay, so let me erase. We know the answer's that one. Okay. I need this. Looking at these two graphs, I did this with Audrey on Friday, and I realized how nitpicky it is because the graph axis, the axes are not counting by 1. If you look at it, you see that? And I feel like that's a gotcha, which is why when we were doing this, I even wrote it on my little post-it to make sure to give partial credit here. You have to look at the axes between your two answer choices, see what they're counting by. So, and it also, to me, it's kind of hard to find the origin. So this is the origin, right? Y'all with me? I'll give y'all markers during the test so you can write on your screen. And then it's running to -10, or let's just go up. So it's running to 8. So this is clearly not counting by 1, check by 2. So 2, 4, 6, 8. So this is counting by 2s, which means this is -2, -4, -6, -8. And then the y-axis, the x-axis, this is 6. So this is 2, 4, 6. This is -2, -4, -6. All right, I'm just going to show you how to write the equation of that graph. We already know that that's not the right answer. And then hopefully that'll help you to understand why this is the right answer. So to write the equation of this piecewise graph, first find your rules. I'm going to do green for rules. This is running with an arrow, right? So that means it's going to -infinity. It's going that way. But where's the rule break? Remember when we took the highlighter and we dropped the vertical line where it's switching from one graph to the other? Do y'all remember that? And then this one's going that way, which means it's going on. So my rules are going to involve -2 and 2. Which we already know that. We can see it over there. Then you say to yourself, how do I get the equation of that line? That line, to get any slanted line, you need y equals mx plus b. You're going to read the slope from the line by reading the rise over the run, and you're going to read the y-intercept from the line by seeing where it crosses the y-axis. So this is your rise over your run. This is where it crosses the y-axis, the y-intercept. The hard part is you only have a piece of the graph. You don't have the entire graph. So you have to look at it and you have to count. It's a counting game. So for this right here, first of all, is it a positive or a negative slope? Look at the line. It's negative because you can turn it into a capital N. I would write that, but I don't have a back arrow. I have to erase the whole thing. So it's a negative slope. Then look at and imagine it was continuing on to cross the y-axis. Look at from here to here, count it. It fell 2 boxes and then ran 1 box, right? Okay, so we're going to fall 2 boxes and then run 1, and then look where I cross. I'm going to cross at 0. Do y'all see that? How I got it? Okay, so for this line, my B is 0. Now I've got to actually imagine what that slope was. The slope was, look how it's counting. I went from 4 to 0. So I went down 4 and then right 2. So down 4, right 2. So my slope is -2. Y'all see that? Yeah, you have to look at all 3 of them. Oh, well, I eliminated my 2, couldn't work, right? And then I'm just pulling up 1 to remind you all of how to read it. We already know this one's not the right answer. Then I'll go to this one to show you the difference between them. But on the test, you're just going to have to pull up one of them and start reading it. So the slope here would be, or the equation would be y equals mx plus b. It's plus 0, so that means there's no plus or minus anything. So going back to my answer choices, look at the very first one. Does my equation here match what I just found? No. So that would tell you that it's not that graph. Go to the other one and check it. Y'all with me? All right, I'm going to erase this, go to the other one, and now we're going to check it. I need this. I don't need the blue. And this was the center. It's counting by 2s. Maybe something like that. All right. So we're checking this one. Okay, my center's a little off, but we're checking this one. Okay, so look at it. Look at the very first one. It's going down 1 box, right 1 box. So go down 1 box, right 1 box. It's crossing at 0 as well. No, that's not 0. Mine moved, didn't it? Let me fix my, there's your x-axis, your y-axis. They come together there. This is counting by 2, 4, 6, -2, -4, -6, 10. So this is counting by -2. All right, repeat. Down 1 box, right 1 box. So down 1 box, right 1 box. So it's going to cross at -2. And now your slope, I went down 1 box, right 1 box. Look at your boxes to see how it's counting. Down means negative, so I went down 2, and then I went right 2. So the equation would be y equals -x minus 2. Yes.
Can I just go to the bathroom?
This line right here, because it's horizontal, think of that acronym POI. Halfway between the origin and -2 would mean it's at -1. So this is y equals -1 right there, and then we already confirmed we have -x minus 2, and because we eliminated that one, you would know that this is the answer choice. Okay. I don't like this question because of the gotcha with the graphing. I feel like the grid should count by 1s, and then it wouldn't involve as much time, but I can't change it. Yeah. Remember, this practice test grade doesn't matter.
I know, but I still
Oh, yeah, okay. It's going down 1 box and then right 1 box. Look how it's counting by 2s. So it's -1, but it's crossing. Yours actually shows where it's crossing. It's crossing right at the origin. So your first equation for that graph would just be -x, which looks like that's not what they have, so that graph can't be right. Go to the other one. That's, so see how there's your x-axis and there's your y, so that's origin, which means your y-intercept 0. Which means your equation for that line will just be -x plus 0 or -x. There, see, there you go. There's There's the negative x. That one's steeper, which makes sense because this was -4. That's why that's the answer choice. Was mine like that? Hey, another little telltale sign. Look at your two answer choices. I wish I could pull them up at the same time. Look right here at these graphs. This has a slope of -1, right? This is a slope of -1, and this is a slope of what? -2. This one's steeper. The third graph is steeper. So if you look at the two lines, all they're doing, this is the same technique every time you hit similar question. Look at the difference in the two lines. They're just switching the slopes in the two answer choices. Like the answer choice here, this has a slope of -2, and this one has a slope of -1. Here, this has a slope of -1, and this has a slope of -2. You can tell by the steepness. Y'all see that? So that's another way to try to, a test-taking strategy that would help. Okay? All right. Let's go to the next one. Ooh, domain and range. Then write the equation for the function. Okay. So remember, domain and range is the union stuff, and brackets do come into play. Y'all hear me? Brackets will come into play, domain and range. It's a piecewise function. You don't let the pieces throw you off. You're looking to see, in terms of x values used for domain, what x values are used. I'm going to do green. So the first x value used, the smallest one, is -9. Do y'all agree? Okay, and then it runs to right here. Then I have an open circle. So you might think, oh, okay, so be careful now, we're switching. But come directly underneath it. What do you notice? There's a closed circle, which means where that graph was stopping, this one's picking up right on it at that number, which means the domain is not breaking open. So keep going, keep going. There's a closed circle, graph stops, but then this one picks up with an open circle directly underneath it. So it keeps going and going and going and then stops at 5. Right? Okay, what if, because I feel like I saw this in the homework one day, what if that one was open? So in blue, my domain would then be, I'm just going to come down here underneath. It still covers, but right there, you would have the union, and then it would be, you would have to show that it's skipping over that number. Does that make sense? If both of the circles that are vertically aligned are open, then it's skipping over that number, and you have to put that in your domain. So in, like, for example, what is that number? -1, -2, -3. If that had been a big open circle, right, then my domain would be -9 to -3, skip it, and then -3 to 5. That would be the difference. The brackets, because those are closed. Yeah. All right, so we've got our domain. The domain's -9 to 5. Then it wants the range. Same concept, but you're turning your head sideways and you're looking at the y values now. Start with the smallest one. So the smallest y value is a parentheses because it's an open circle. and it's covered all the way up to there, which is another parentheses because it's an open circle. So it would be -4, 2, 7, 8. Okay. Now, how do you write the equation for it? Okay. You've got 4 answer choices. You need to use the process of elimination to figure out which ones you have. How many pieces are there in the graph? There's 3, which tells you it can't be this, and it can't be this. The next thing you look at is the holes to see, and any arrows, holes or arrows. So if you look at the graph, let me open it up. Notice that this is closed to open, closed to closed, open to closed. Do I have a single arrow anywhere? No, I have between, right? So if I go to my answer choices, look at the rules. Look at the rules. These rules here mean between. These rules here, this means you're going to shade left. This means you're going to be at a number, which is a point, and this means you're going to shade right. Did we have that in the graph? No, we did not. So this is not the possible answer. That puts you here. Now you're going to have to do the same thing we did on the last example, which is why I spent so much time doing that, because I knew it was coming up. You get the rules by looking at the graph and finding your vertical breaks. Take a highlighter. You got a vertical break here, 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 and here. So the first graph from the left is running from -9 to -3. The second graph is running from -3 to 1. And the third graph is running from 1 to 5, which I don't know if you can see, but the rules are muted, or the graph is, the equation is muted. You can see how that goes in. So -9 to -3 is the first one, -3 to 1 is the second, the middle one, and 1 to 5 is the last one. Now you got to get the equations. Now you've got to get the equations. So I'm going to erase this because now it's getting crowded. All right. So the equation here, this is slanted, so y equals mx plus b. Count the slope, rise over run, then keep counting it to find where it crosses the y-axis. This is rising 1, running 1. Do y'all see that? So just keep going. It would cross right here at 11. And the slope was 1 over 1, right? So the equation of that would be x plus 11. With me? Here, it's rising 2, running 1. So my slope is rise 2, run 1. I need to know where it's crossing the y-axis, so just reverse. Go, what is it? It's left 1, or you can go the other way. Let me erase that. You can count. How do you get from one to the other? You go down 1, left 1, or down 2, left 1, down 2, left 1. It's crossing right there at -6. So the equation here said the slope was -2 over 1, or -2. So it'd be -2x minus 6. Or mine's not negative.
Are we coming back there as well?
Some people are. The middle one, right here, that's the HOI. It's a horizontal line crossing the y-axis at 4. and because it's horizontal, it is just the number 4. This one? That? No, you're rising 3 and going right. So remember, it's 3 over 1. Remember, it's, well, I was counting backwards to get to, so the slope here is rise 2, run right 1. But in order to, so my slope is positive 2 over 1. But in order to find where it's crossing the y-axis, I had to go in the reverse direction to count it out, which means down to left 1, which is the equivalent of negative 2 over negative 1, which is still positive 2. So I need to do the same thing. You need to, yeah, to find out where yours is crossing the y-axis. Yes, it's at 3x negative 9. What? Is it telling me first? It's negative 9, negative 30, negative 30, 1, 2, 3, 4. Alright, and then first equation is slope 1. And it's at 10. So 1x plus 2. Your middle graph is crossing the y-axis.
Yeah.
Oh. And your last equation. Oh, listen, just remember. Hi. Oh, I don't have as big of a cart as they do.
Yeah, it's so much more.
Oh, okay.
I just said, where's the cart back
Yes.
at?
I think so.
It's that. Remember, negative slope is if you take it into a negative end. Yeah.
Yeah, we have some.
That is your slope. Like, I'm like, yeah, I would just count it because I find that a lot easier. Let's say that.
Oh yes, good.
There is one 14-part question.
Oh, dang, really?
There's 2 14-part. That was. I'll check the test. I know that for sure there's one.
That was terrible. She's at lunch.
It's one thing, but
Terrible.
he is positive.
For the, or like, 6
6 or 10. All right.
I was kidding.
Okay, so fractional.
There you go. We probably got it
Of course, yes.
Just hold on to this. No, you need to come over here.
I got this.
Howard Road. Yeah, 3x over minus the Yeah. Okay. Can you, it says visually, so can you reflect it over the x-axis and match? Fold it down and match. So, and this is, but you have to pay attention. Yeah. Right. And the next part's going to be over the y-axis. Same question. So if you folded it, would they match?
Yeah.
Would they match? So that one's yes, but you have to make sure you pick the correct one. Yes. Now it's going to say the origin, which is where you rotate it 180.
You work there.
You flip it upside down. So pick your computer and turn it upside down. Does the graph match? Yes. Right? Turn it back right way. Look at it. Now turn it upside down. Does it match? No. And that's 180 degrees. Wait, domain and F? Yeah, what's the domain, not the equation? Just the domain. All right. Okay. I know. What's wrong?
Yeah, we were at work. What's that fight?
You'll type it exactly how it looks here. It takes care of that negative. But you've got to remember to put parentheses there. Okay. Yes. Looking at number 6, it says you've got F, you've got G, and then it says find G minus F of 0. G minus F of 0. Guys, remember, if it's a number here, that means your answer will be what? Answer will be a number, right? You do have to set it up, so we have G, which is 3x plus 7, then minus F. You have to put parentheses right here after a minus sign, or it will give you the wrong answer. And you can go straight to your calculator and you can type this in, but in your calculator you would enter 0. You'll get
'Cause over the summer, it was like 2 or 3 years ago. The summer, she said I played it.
back to 7 and 8. All right, let's skip to 18. Okay, which was the one that was the graph? Since these kind of blend together.
9 or 11 or
Was it 17?
no, it was like
No.
9 or 11.
What the milk?
Like it's 9.
What graph is it?
I do too.
Oh, which graph are you talking
The
about?
one, Madeline Everett, do you remember which one you were just on and you were asking about the even, odd? Oh, that was, is it this one?
No,
Age. I
it
still
was
smell
question
rubber.
like 19. No, it was 18. Oh, it's 17.
Okay,
17 is the graph.
all right. So let me back it up to 17 because 17 blends into 18. All right. So on 17, determine visually. So this means, y'all, that you're not worrying about algebra. Don't plug anything in. You're just looking at it and answering the question, okay? It does say whether it's even, odd, or neither. Here's where it's like a gotcha, and I don't agree with it. You will notice it's listed even, odd, or neither, but then it comes here and it lists it in a reverse direction. When you're doing these symmetry problems, always start with even, then go to odd, and then of course the last would be neither. The reason why is because the even is when it will flip over the x-axis, right? Or not the x-axis, sorry. It flips over the y-axis. I think I told you x-axis. Hold on, I'm thinking of.
Isn't it x goes to
Remember,
negative x?
yeah, remember the y equals x squared? Remember me saying this is an even power? And this is the mother function?
Sorry.
And it will flip over the x-axis and it's symmetrical. Or the y, I did it again. Hold on, let me read.
No, but isn't it like you
thought
usually go
it flipped down.
of it as x to yield negative x?
Right,
Right? That's
right.
what's flipping on the y.
It's flipping over the y.
Okay.
It's flipping over the y-axis. The positive x becomes a negative x. And you're answering whether it's the same graph. Right? So if you take this and you fold it, think of wet ink. Think of someone that just freshly painted that graph, and then they're going to fold it right in half. Would it match? And the answer is no. So it is not even. Now, odd. Odd symmetry. Odd refers to 180-degree rotation. So look at the graph, then take your Chromebook and flip it upside down and see if it's the same graph. And if it is, then it's odd. It has odd symmetry. If you flip this upside down, you should notice it's the same graph.
It's like someone that it's X's becomes negative and Y becomes Merry Christmas.
That's the odd. Yeah, if you're checking algebraically, it means X became negative and Y became negative, and you ended up with the same answer.
Okay, I'm having trouble. How are you?
I gotta go to 18 real quick, and then I'll go to yours.
How are you flipping 180?
No, it's not a flip, it's a rotate. Yeah. Take your Chromebook. I have no problem with you doing that during the middle of the test.
online tests.
No. I have no problem with you doing that. And you're just asking yourself if the graph is the same.
It is indeed.
Alright, so there's 17. Now, the reason I did 17 is because it blends, like leads into 18. Here's 18. Notice this time it's not saying visually, it's saying algebraically. This is what you're going to have to remember. Remember. Okay, if it's even, that means x becomes negative x, and you're checking to see if it's the same equation. If it's odd, you've got the x and y's become negative, both of them, and you're checking to see if it's the same equation, okay? That's why it's helpful to do even first, because there's just the one thing to check, then odd second, because you're checking both of them. Alright, so we're going to plug negative x in to this. What is it? F of x equals 6. Right? If I plug, this is kind of a trick, but if I plug negative x into this, is there an x at all? No. So what comes out of it? 6. I still end up with this, which means it's the same, there's no x. So it is even, which means you're done. Because it'll never be even and odd. That's not
How's it even?
because there's no x there. I know, it's silly. Hey, Adriana, you're sitting right by a microphone, and I'm recording for my college kids.
Oh,
So you might want to either move or mute your phone. So there was no x here to plug it into, so you end up with the same function when you check negative x. Had there been an x right there, then you would have plugged negative x in, which means it would be negative 6x, which would not have worked. Does that make sense? Alright, so that's 18. Okay. Y'all want me to go back to 7, which was 14 parts? Yes, 11. Okay, I'm going to do 11, then I'll go to 7. Alright.
What about me? Eight's the same thing, but it's just a little
Yeah, but
harder.
I'm already halfway done.
Okay.
Let's see.
Okay.
Okay, 11.
Eight's gonna be harder, man.
11 is 3 parts. The first part is find function p. And if you notice right here, they're telling you that function p comes from function r minus function c. The trick here, the gotcha, anytime there's a minus, what needs to come right after it? Parentheses. So the trick here is to remember that when you write the minus, the very next thing needs to be parentheses, and then you're going to distribute that negative. Okay? The next part is just plugging it in. So like this is saying plug 90 into function R. You just type it in and see what you get. 90 in function C, 90 in function P. Just subtracting, yeah.
Are you going to be here for 6 months?
I need to check with my husband and make sure. I can let y'all know.
Because I have to go back to Coach Shell's and do one fucking thing.
Okay, I can let you know. home if I'm gonna be here. If I'm not, it's because I'm going home to this sick kid. But I'm on my phone. You've got me on remind. The last one is saying now graph all three. Look right here. Use a graphing calculator, graph all three, and then they tell you the window. So you're typing R in one of them, you're typing C in another one, and then you've got to type your function P in another one.
Not with the one using it.
Yeah, no numbers, none of this stuff. Like the it's got the S.
Okay.
Well, mine's saying it's wrong when I typed in.
Make sure you're using minus signs instead of the little negative. I'll come look at it.
So what are you doing besides plugging stuff in?
Well, the first one you're subtracting the two functions. The first one is subtracting R minus function C. You have to distribute the negative. The second one is plugging in numbers and evaluating, and the third one is matching the correct graph. You have all three that you have to type in Y equals. You got R, C, and P. And then you have to change the window to this right here. And then it's just match it.
So it's going to show that graph on the
You've got to type all three.
Okay.
Look, read it. Use a graphing calculator to graph all three. You got to type that one in, that one, and that one. And then you have to do this window, or you won't see it.
Okay.
All right, 7. Okay, is 7 the first one that's 14 parts? Okay. 8 is with the linear and then the fraction. Okay. 7's harder because of the radicals. Because instead of, hey, you just skip over this number, in 7, it's, hey, you got to stay above this number. You know what I mean? Remember, with radicals, the radicand, which is the part underneath, has to stay greater than or equal to 0. Can't be negative. That's what you've got to remember. So like right here, the domain for F would be that X has to stay greater than or equal to 3. And I get that by setting, let me come over here and write it. Let's do F. It's X minus 3. Okay, so I would take the radicand. So X minus 3 greater than or equal to 0. And you would solve that. So add 3. So there's the domain for F. Then G is X plus 3. All right, take that out. Greater than or equal to 0. Subtract 3. Okay, so then might help with the number line. So this one's saying at 3, close and greater. This number line, notice I put both numbers on there so I can really see the visual. I'll hand it to you. All right, so now I've got my number lines.
It's just a help.
Sam, were you here Friday? That's why. It's over there. Is there not over there? Oh, your name's not on it. There was a ton out Friday. I didn't write the names. But let me grab an extra one just in case. Or you can grab Alex's because I don't think he's here. It's this one. All right. So now I can see what numbers are allowed to go into F. It's anything 3 or higher. I can see what numbers are allowed to go into G. It's anything -3 or higher. And then now you have to check it. All right, so domain of F, that would be bracket 3 to infinity. Domain of G, that would be bracket -3 to infinity. What if this is really intimidating.
It's just the lower.
Yeah. This is saying, hey, add them together. Okay, so if I was to add them together, you got to ask yourself, what's the smallest number that is allowed in both of them? And that would be the overlap. So that would be like right here. The smallest number that can go in both of them would be 3. So an easy way to think of it too is to ask yourself, like, can F of -3 work? Meaning, if I plug -3 into F, will I get an answer? And the answer is no, because I'd end up with a -6 and can't have the square root of a negative. So that's why this is the most restricted. Now, the next part, right here, watch out for fractions. You have to be careful. Focus on the one in the bottom.
So then we do that, and then we already got the G.
So, because we have F over G, it's still the same thing. You're dealing with both functions, so you still can only start at 3.
Okay.
-3 can never go into F, ever. Doesn't matter how you slice it, I guess you could say. But the question is, can I have 3 in the bottom of my fraction? So, coming over here, if I have F over G, it helps me if I write the fraction. F is square root of x minus 3. G is square root of x plus 3. And then I go next to it, and I usually change pens. I go next to it and I tell myself, okay, what's allowed here? This is x is greater than or equal to 3, right? And then we know this, because of that restriction, come right here, plug 3 in. Can I plug 3 in the bottom here and get an okay number? Yes, which means bracket on the 3. Now, what if I switched it to G over F?
And then it'll be a consistent, you can't do it.
So remember your restricted domain is x has to stay greater than or equal to 3. But if I plug 3 down here, I'm going to get the square root of 0, which is 0. Why is it not writing? Which is 0, which is a problem. So you would tweak this by saying, okay, it's not that, it's x just has to stay greater than 3, which is parentheses. That's the difference there with those two. I'm trying to remember on the test. I know there's at least one question that's 14 parts. I did make, I made this for y'all, this answer sheet, so that you have like hints along the way.
Okay.
Like, simplify your expression before typing it in, which would mean like either multiply, subtract, add, whatever it was. I have, interval notation. I have make sure to use a comma, or I have make sure to use union. I'm going to give that to you on your test.
I'm struggling to know when to simplify it.
The little blue part, the blue part tells you when to simplify. The words.
Oh no, I got some. I'm on
Is it 8?
I'm on 8.
All right, I'll go to 8 next.
Okay.
Are you on 8? Yes. Yes.
I had all
Yeah, the only tweak is,
having fun consolidating.
now when you do this one, see right there?
Yeah.
That one right there. Oh, and that one. So let's look at it. F times G would be square root of this times square root of this. They want you to notice that that's one big square root, and these are a difference of squares, which is the first outer inner last, and you'll end up with x squared minus 9, and that would be the answer. When you do F times F, because that is something times itself, they cancel, and that's why it's x minus 3.
With the fractions, do you keep it already? Like, you just plug it in.
What do you mean? Like, see, here's how they did theirs.
Okay, yeah.
Yeah. Alright, I'm gonna pull 8 up. Let me look. Hey guys, there is only one 14-part question on the test. Just one of them. I don't know if it's the radical or the ones where it's fractions, so you need to be ready for both. Which is why they're both in the review. Are you still in 7?
I don't know why it has my name. Oh, it moved to the next question.
My 7's changing every time I change. Oh yeah, you're on the next question. Okay. So this one is watch out for fractions. You cannot have what in the bottom of a fraction? 0. Which means that you're just skipping over the numbers that would make the bottom 0. Which means this should be easier. It's just a big old shaded number line, but put open circles on what would make the bottom 0. The harder one is the square root one.
Already? Who have you told? Wait. From Saturday, right?
Okay, look at this. Look at this. Square something that's in square root. Which means if you're doing square root.
Go for it, please. Knock on it. Knock on
No, we need them.
Where's the stuff? Where,
it. Getting us something?
Miss
Let's
Holcombe,
go let him in.
Yeah.
where's your thing?
Oh, that's what it is. He's handing you the. Here. I think it's in my lunchbox.
I got onion rings. It's got something.
So, let's see. So the domain for F, X cannot be 0. The domain for G is all real numbers. Okay, so far Here's what I like about this one is when you got your, you can do your number line, find zero, and you already know like, okay, gotta skip over zero. I am. So then when you come to, so all of these are easy. You just gotta skip zero, except for that one, of course, it's just G. When you come to a fraction, alright, so F is this big fraction bar, G is this.
Zero or whatever is in the fraction.
Right, so we're gonna keep, change, flip, keep it, change it. This is understood to be over 1, so flip it. And then you don't really have to even multiply. You can just look at it right here and say to yourself, okay, x can't be 0 and x can't be 7, which is why it's skipping over both. Now when it's G over F, that's
know the
not an
ice guy?
issue, so that's why it's, for mine, it's only x can't be 0. Just skip over.
You've never seen that? The black guy where he's talking to his wife and he's going to save the city or whatever.
They don't want common denominators. Look, with the minus and the plus, they just want you to write it. You don't have to get a common denominator.
I don't know because I haven't printed it out, but I'm going to it yet. Solving, so the main figured it out like this. But solving,
I mean, this part, this stuff, okay.
because the fractions, but I can't, I can do lunch.
Right. Oh yeah. Hey y'all, don't forget to go to lunch. College students, make sure you. Let's see. So this.
Yeah, they were mad.
Oh, for real?
F is 6 over x over G over This would be
Yeah.
keep, change, flip.
There would be x squared.
Yeah, this is a binomial, so it's going to multiply into it.
Okay, see, I just didn't.
Andy, make sure that's not water.
It's easy over fraction. Alright, keep, change, flip.
Is it water?
6. Still, this is all in number 1. That's still x squared.
Stop sign, the first stop sign of the
And I think that's, yep. I think it was this one. Just look, that's plus. You have a plus sign between. Minus, you do have to distribute.
But if they don't leave this weekend, next weekend they're supposed to be going to Missouri.
This is
I don't know if they're
times.
staying there.
That one, alright. So 6 over x times x minus 7
When they left Friday last time.
over 1. Okay, so that's 6x minus 7.
Did they ever tell you before they left that
Sometimes that day, sometimes they play. Like, they would cruise plan for Christmas.
Told me about us.
Thank you.
It means on
Yeah.
sleep.
Alright,
You doing that?
so
Big angle, big. It's not a big
find f of x plus h first. So you got 3x plus h squared plus 6x plus h plus 5. Find that first. So this is me finding this first. Okay, first outer inner last. Distribute.
So I tried to look on this one. She shows this one.
Are you serious?
I don't know. Yeah.
Distribute the 3.
I think we're showing this one. You're telling me I don't know.
How did you do that?
I can see it. Then there's nothing I can do. Okay, so now I gotta take, that's that. Now I've gotta find minus f of x. So I'm gonna come right here and say minus, parentheses, f of x. Why is that messing up?
How big this one is.
I just did your choice.
Where did you get 2x?
It's in production.
Right. Never mind.
First out or inner last?
I need you.
Yeah. All right. Now I can distribute the negative. So this crap comes down and I got minus 3x squared minus 6x minus 5. So I can cancel 3x, cancel, yeah, minus 6x plus 6x plus 5 minus 5. So I'd be left with 6xh plus 3h squared plus 6h all over h.
Don't complicate it.
Okay.
That would go.
How
Go.
do you do with that?
This was like, isn't that like,
Plus 6. All right.